So last class, we learned the difference between a function and a relation. And we now know that a function is very specific because for every x value, there's only one value for y. And we know how to figure it out using a table of values, using coordinates, using mapping diagrams, and also the vertical line test from a graph. Now that we know what a function is, we're ready to learn something called function notation, which is like a specialized mathematical symbol that you use to represent only a function. So we're going to go through the first two handouts, which is really just introducing you to the topics. And then the third handout will actually get into calculations. So right along with me, a function is a relation in which each x value has exactly one y value. And then today's class, we're learning function notation. Is a mathematical notation that describes a specific function. So really, all of the math we're doing today is not new. You've learned the math before. We're just learning a new way to write the things that we used to write before. So whenever we're naming a function, we can call it any letter you want, F, G, C. I would say like 90% of the time, I always see an F, but it doesn't matter. You can call it any letter. And then the independent variable, which is like usually represented by your X, is written inside brackets. So here are three examples of function notation. And the way you say it is you say F of X, H of T, C of N. And if you were to break this down, what it means is the letters in the front are the names they're names of your functions. You're calling one of the functions letter F, the other one's H, the other one's C. And the numbers inside of the bracket represent your independent variables. So it's usually your X's, but in this case, you can call it your T's or your N's. Your output, which is your Y values, are whatever F of X, H of T, and C of N are. All of this seems confusing, but when we get to our examples, it will start to make a little bit more sense. So just, keep an open mind. For example, the function y is equal to 2x minus 4 can be expressed in function notation. The table and graph of the function remains the same. So I would say you learned something like this in grade 9. We would give you an equation like y is equal to 2x minus 4. Then we would ask you to make a table of values, which you all know how to do. You pick any value for x, substitute it into the equation, and then you get your value for y. And then you graph it and you label it using the equation. Now, in grade 11, what's changing is we're using function notation. So instead of the letter y, whatever you have for your dependent variable, you're going to now replace that with function notation. So where I had my y before, now it is f of x is equal to 2x minus 4. Whatever letter you put inside the bracket, make sure that letter is found in your actual equation, or else it won't make sense. But look at what happens. Your x values are still the same. Now, instead of a y, you're writing f of x, and your graph is still the same. But now, instead of writing the entire equation, you're just going to label it f of x. So the math is all the same. We're just naming it a different thing. What's the point of this? Like I said, mathematicians are lazy. So anytime they can use shortcuts or short forms of stuff, they will. And I like to think this is just like a shortcut of what we used to do before. So let's try example number 1. It says the equation y is equal to 0.85x represents a function. Rewrite y is equal to 0.85x using function notation, and then name the function using the first letter of your name. All of us are going to have something a little bit different. So I'll give you my example. My first name is Juhi, which starts with a J. So I would label my function j of x is equal to 0.85x. So whatever your first name starts with, you're going to label your function that, and then you're going to have bracket x because we noticed that our equation has an x in it, so we can't change that. That has to remain an x. Okay, now here's something interesting. I like rarely find this, but does anyone know like any Xaviers or any name that starts with an X? those are hard to find. They're the only people that can't name their function with the letter x, because you can't have x of x. It gets too confusing. You don't know what's happening. You have two x's. So that's why anyone whose name starts with an x would have to label it with something else. That makes sense? Okay. Example number 2, we're going to rewrite the equations below using function notation. But the first thing we need to do is we need to have y by itself. So we're going to isolate for y. And then the instructions say name the first function f of x, the second function g of x, and the third function h of x. So step number 1 for all of us is going to be to rearrange all of the equations so it's y is equal to something. So for the first one, I'm just going to move the y to the other side, the 6 over, and when I do all of that, it's going to become y is equal to 1 over 4x plus 6. And according to the instructions, they want us to label the first one f of x. So it's just going to be f of x is equal to 1 over 4x plus 6. Should it be, sorry, you guys, should it be minus 6? Yeah, you're right. It should be a minus 6. Okay, the second one, all we're going to do is divide every single thing by 8. So it's going to be y is equal to 3x minus 10. And then the instructions say, let's label the second function g of x. So we're just going to write g of x is equal to 3x minus 10. Okay, and the last one, I'll move the y over here. I'll move the negative 9x over here. So I'm going to get 9x plus 2. And then we're going to label this one h of x is equal to 9x plus 2. So one thing is for sure, what letter in our original equation does the function notation replace? The letter y. Does the x change? No. If I were to change the x in the equation would also have to change. So if we were to say h of t, then it would become 9t plus 2. Okay, let's keep going. Evaluating functions using function notation. So the blanks here are, since function notation relates the input and output, which is just the x and the y, it can be used to indicate how to evaluate functions. Okay, so let's look at an example. If g of x is equal to 5x minus 2, what is the value of g of 6? Whenever you see something like this, what it means is they're asking you, when x is equal to 6, what is y equal to? So if the number inside of your function, inside of the bracket is, if the letter is replaced by a number, they're asking you to replace every other letter in the equation with that number. So we write g of 2, and then we have 5x minus 2. So it'll be 5 times 6 minus 2, which is just 28. Okay, and the steps are kind of outlined here. G of 6 means evaluate at x is equal to 6, substitute 6 in for x, and then simplify. Let's practice doing this. So example number 3, given P of n is equal to a half n minus 5, what is the value of P of 9? So what this question is really asking is, it's asking when n is equal to 9, what's the output going to be? So the way I would write this is P of 9 is equal to, and wherever I have an n in my equation, I am going to replace it with a 9. So a half stays the same. N minus 5 is now 9 minus 5, and then the square still stays the same. Does everyone see how I did that? Like why I replaced the n with the 9? Okay, to solve this, n minus 5 is 4, 4 squared is 16, half of 16 is just going to be 8. So P of 9 equals 8. You guys notice that the math is still what we did in grade 9 and 10? Nothing changes, just notation. Okay, let's try the next one. for this one, if f of x is equal to 7 bracket 3 minus x, what is the value of f at -2? So they're saying replace all of your x's with -2 and then solve. So f at -2 is equal to 7 bracket, just be careful of the double negative, so minus -2. 3 minus -2 is 3 plus 2, which is 5. 7 times 5 is 35. Yeah. The number besides f? We can, no, that's just like your y. Yeah, that's just what you're saying is part of the question. Okay, go ahead and try the last one. I will do it up here and you guys can check your work. So negative. Okay, the last bit before we get into like actual calculations, evaluating functions from multiple representations. A function can be evaluated using various representations of x. Various functions are represented below. And you guys are familiar with these, right? We have coordinates, table of values, mapping, and a graph. So let's just look through it. They're asking us to figure out for every single one of these examples, what is f of 2? All that really means is when x is equal to 2, what is y equal to? That's like the traditional way of thinking about it with your x and y. So they've already done the work. In a mapping coordinate, this side represents your x, this side represents your y. So they figured out that when x is equal to 2, y is equal to -12. Just be familiar with how they note down how they write it down. They wrote f of 2 is equal to -12. In the graph, when x is equal to 2, you just go down until you can find what the parabola is sitting at. And in this case, f of 2 is just equal to -2. For a list of coordinates, you find the value x, and whatever it's paired up with is your answer. So in this case, f of 2 is equal to 10. And in a table of values, again, you look for where x is equal to 2 and whatever it's paired up with. And in this case, f of 2 is equal to 9.25. Go ahead and try this for example number 4. And I shall do it up here as well, and you can check your answers. And just be mindful of how you're writing your answer because we're practicing our new notation. So make sure you don't just write the answer, you write it as f of -3 is equal to whatever the answer is. And then for this one, when f is -3, y is going to be equal to 4. Okay, so more function notation. The examples are there. Let's get right into question number 1. Question number 1 says f of x is equal to x squared minus 2x. And then g of x is equal to 3x plus 2. That's a second function. And the last one is h of x is equal to -x plus 5. Depending on what the question is asking us for, we're going to be selecting which one of these functions we're going to use when we answer. So let's look at the first one. It says 3 times g of x. So we're going to write the g, 3, and g of x is what? What's the equation for g of x? Yeah, so we're going to replace g of x with the entire function 3x plus 2 plus 2 times f of x. What's f of x? X squared minus 2x. we're just going to expand, and they just want us to simplify. They're not asking us for any answers or anything like that. So we're just going to simplify as much as we can. 9x plus 6 plus 2x squared minus 4x. This is 2x squared plus 5x plus 6. Now, if it was saying find x, we could probably keep going and solve this. I wonder if we can factor this. Can we factor this? 2x and x, and 3, 4. It doesn't seem like we can factor it unless we try maybe 6 and 1. 12. Nope. So we're just going to leave this as the final answer. Let me know if you guys can factor it, because I'm not seeing it right now. Okay. On to the next one. This question is saying, what is f of x squared? So we're going to take our function, which is f of x. I'm just going to write it here so we can all see it. F of x is equal to x squared minus 2x. And now this question is saying, replace all of the x's in the question with x squared. So the first x, I'm going to replace with x squared, and it's going to be x squared to the power of 2. And the second x is also going to be replaced with x squared. Okay, I'm going to keep going. This is going to be x to the power of 4 minus 2x squared. And if we wanted, we could just factor out the x squared and be left with x squared minus 2. Is everyone okay with the first two examples? Yes. To wear them. Okay, sometimes you can replace a function, a variable in a function with an entire binomial. So in this case, it's f of 2a plus 1. I'm just going to write the function f of x is equal to x squared minus 2x, so I can see it up here. And now what I'm going to do is, wherever I have an x in my equation, I'm going to replace the entire thing with the entire 2a plus 1. So it's going to be 2a plus 1 squared minus 2 times 2a plus 1. You are going to have to do a little bit of work. So this is going to require FOIL and distributive. 2a plus 1 times 2a plus 1 will be 4a squared plus 4a plus 1. So I FOILed that sort of in my head using the rules. 2a times 2a is 4a squared. And then 2a plus 2a is 4a. 1 times 1 is 1. And this is going to be negative 4a minus 2. And now we just simplify. So we're going to get 4a squared. Positive 4a minus 4a disappears. And you're just going to get minus 1. Now you can factor this. I'm not solving for anything. We're just simplifying right now. You could actually factor this and get an answer for a, but let's not worry about that right now. We're just practicing solving it. Okay, here is what I think, Ariane, you were talking about. What happens when you have like multiple functions within each other? I like these questions, so you're definitely going to be seeing these quite a bit. What I like to do is I like to break it down. So see how it's f of g of 3? Always begin with the innermost function. And in this case, the innermost function is g of 3. So what we're going to begin is start is we're going to simplify this right here, which is g of 3. Okay, so I'm just going to scroll up. G of 3 is going to be 3 times 3 plus 2. Because if you look at the top where I've highlighted in yellow, g of x is equal to 3x plus 2. Now we're replacing every single x with the number 3. Okay, when we solve this, g of 3 is just going to be equal to 3 times 3 is 9 plus 2 is 11. So g of 3 is equal to 11. Now for the second part of this question, what we're going to do is, we know g of 3 is 11. So really now we're trying to figure out what is f of 11. So anytime you have a function within another function, you're going to have to do multiple different steps to figure out the final answer. Start with the innermost function, solve it, then put that number into the bracket and replace it, and then now solve this. So f of 11 is going to be 11 squared minus 2 times 11. Because if you scroll up here, the orange highlighted function, x squared is going to be 11 squared because we're substituting, where is this coming from? There we go. Okay, so let's solve this. It's going to be 121 minus 22, and this is just going to be 99 is our final answer. By the way, you guys, anytime your function has a number inside of it, like in the first 3 examples, there was no number. It was x squared 2a plus 1. So you're not going to get a final answer as a number. But if the question is ever giving you an actual number for x, chances are your final answer will be a numerical answer. How'd you guys like that example? It's a little tricky, right? Okay, let's do 2 more like this. How do we solve g of h of x? Okay, let's write out the functions first. So g of x is equal to 3x plus 2, and h of x is equal to negative x plus 5. I've just written out the functions because I'm not scrolling up, so I want to be able to see them. To solve this question, they're basically saying you want to replace all the x's in your g of x, this one and this one, with this entire function. So you want to take this entire function and put it into that x, and then you want to replace all of the x's in g of x with that function. So how are we going to write this down? I'll show you the notation. We're going to say g of, and the entire function h of x is negative x plus 5. And then we're going to put this into the function g of x, this one right here. So it's going to be 3 bracket negative x plus 5 plus 2. Is this going to give us a numerical answer? No, because they haven't told us what x is. So we're just going to simplify it until we get a simplified expression. Question 3? So that would be our final answer. Second page is a little bit more challenging. All right, the last question of this page, let's try it. We have, I'll just write the functions because I can't scroll up. So f of x is equal to x squared minus 2x, and g of x is equal to 3x plus 2. So we're going to take both of these functions and we're going to decide what is going into what function. I'm going to replace my x's in my f with 3x plus 2. So this is basically f of 3x plus 2 is equal to 3x plus 2 squared minus 2 times 3x plus 2. Okay, so we just took this entire function and put it into all of the x's in f of x. And now it's just algebra, so go ahead and solve this by expanding and then distributing and simplifying. I'm gonna do it here so my little narwhal doesn't get affected because he's just so cute. Okay, we're gonna get 9x squared plus 12x plus 4 minus 6x. I feel like we did this already, but maybe with different functions. Then we have 9x squared plus 6x. That's it. 9x squared plus 6x. If you wanted to just factor out a 3x, we would get 3x plus 2. Okay, how do we analyze a graph using function notation? Let's try this. The graph of y is equal to f of x is shown at the right. It's just a scatter plot. Question A says evaluate f of -3. So the question is basically saying when x is -3, what is y equal to? So you find x is -3 is right here. What is this y value going to be equal to? -1. So I just wrote it out like this for you guys to make it easy, but really the proper way is f at -3 is equal to -1. Question B, which is greater, f at -1 or f at 4? When x is equal to -1, what's y equal to in this question? So when x is -1, y is just going to be equal to 0. And then when f is 4, y is going to be equal to 1. So which one of the functions is greater? F of 4, which is equal to 1. You like this? You don't like this? For what values of x is f of x equal to 7? So for this question, they're saying when y is equal to 7, what is x equal to? That's basic. It's kind of backwards. So I'll repeat it again. For a question like this, they're saying when y is equal to 7, what is x equal to? So when y is equal to 7, what are the two values for x? Yeah, so x is going to be equal to 1 and x is going to be equal to 3. Because look, there are, when y is 7, there are actually two answers. One is here and one is there. The two answers for x are x is equal to 1 and x is equal to 3. You don't. It just says for what values of x. So you're just writing out that. Question D says, for f of -4 is equal to 2 and f of 6 is equal to -6, plot the points. So if we know our function notation, we know your x value for this first one is -4 and your y value is 2. And for this, your x value is 6 and your y value is -6. So really the pattern is this number is always your x and this value is always your y. Okay, so just go ahead and plot those. -4, 2 would be, and then 6, -6 would be right over here. I made a mistake graphing. -4 should be +2, so it should be up there. Okay, suppose f of x is equal to 6x squared minus 50. Find x so that f of x is equal to 46. What we're going to do to solve this question is we're going to take this, f of x is equal to 46, and we're going to replace it over here, and then we're going to solve. So you may not be able to see it initially, but once we do this first example, it'll be so clear to you. F of x is now 46 is equal to 6x squared minus 50. Okay, so all we did is we replaced the f of x with 46 because they told us f of x is equal to 46. Now they're telling us we need a specific answer for x. So we're probably going to have to factor. I'll move the 46 to the other side, and this will give us -96. I'm hoping when we factor out stuff, it'll become a nice, easier number. 36, so this is going to be 16. So when I factor out a 6, I get x squared minus 16. This is just a difference of squares, so it's going to be 6, x plus 4, x minus 4. So my two values of x are x is equal to -4 and x is equal to +4. Okay, we're gonna power through the last questions and then we're done. Question number 4 says, let f of x equal to 4x squared minus 1 and g of x equal to 2 plus 4x. Determine values of a such that f of a is equal to g of a. So for this first example, what we're going to do is we are first going to replace our function f of x with the letter a. So this is going to be 4a squared minus 1. And then we're going to replace our g of x function with the letter a. So it's going to be 2 plus 4a. Okay, so really all I did was I wrote the f of x function on the left and changed the variable to a, and the g of x function on the right and changed the variable to a. Now you're going to move everything to one side, factor, and solve, because they're actually asking us for values of a. Okay, so it's going to be 4a squared minus 4a minus 3 is equal to 0. Let's try 2a, 2a, 3, and 1, negative and positive. And then to solve for each one of the values of a, you just change, you see it's kind of like when we used to do restrictions. So a in this case is going to be equal to negative a half. And a in this question is going to be equal to 3 over 2. Try question B yourselves. I'll put the answer on the screen and then we'll go over your homework and you guys can start on it. Okay, so 2 of a means I'm going to have 4 bracket 2a squared minus 1. And this is going to be 2 plus 4a squared. Okay, so this is going to be 4 bracket 4a squared minus 1 is equal to 2 bracket 4a squared. And this is going to be 16a squared minus 4a squared minus 3. It's going to be 12a squared minus 3 to 0.